guys want to talk about today? It's your review day. So what are the things that you're stuck on? Yes. Limits and piecewise defined functions. I'm just making a list over here of stuff. What else? Limits and piecewise defined functions. Yeah. Brenda.
I guess recognize and incorporate the product and quotient rules in applications.
Yeah. Okay. So, product and quotient. In applications. Okay.
Maybe like any revenue, cost benefit type of stuff. Maturity ones.
Revenue type problems. Okay. That's a lot to go on. So let's start with this and see how far we get, and time permitting we can cover other topics. Gertie? And the beast? Okay. Yeah.
Question 54, 9.4.
54, 9.4. That's low priority because that's homework. So if I get to it, I'll do it. Otherwise, come find me and we'll talk about it. Or you can call me this weekend and we'll talk about it. Ruby? Okay. All right. So, yeah, let's do this, guys. Oh my dear God, that song is, it's awful. It's awful. It's gonna make me hate that band. I love him. Oh well. Limits. Let's start with the visuals of limits. Let's say this is 10, this is 3, this is 7, and this is 11. I'm going to ask you guys a series of questions about this little piecewise defined function. Do you guys see why it's a piecewise defined function? We have one curve up to not including 10. We have another curve past 10, not including 10. And then we have a dot right at 10. So this would be a piecewise defined function, where we have something for x less than 10, we have something at 10, well, I can tell you exactly what it is, it's 11. And then we have some other function at x greater than 10. So this is some piecewise defined function, right? Okay, so if I ask you to take the limit as x approaches 10 negatively, where are you going to be coming from? Not you three. Because I know you practice now. Because I know you know it. Yeah, we're coming at it from the left. Why the left, guys? Yeah, so the convention is your left hand is the negative side and your right hand is the positive side. So if we're coming at it from the negative side, we're literally going to look at 10. I'm going to find the road to the left, and I'm going to drive at 10 with my left car or my hand or my finger or whatever it is you're using. And where do I crash? What y value? 3. What's the limit as x approaches 10 positively? So now we're coming at it from the right-hand side. Yeah, it's going to be 7. Does everyone see that? I'm standing at 10. I'm going to find the car or the road, because I need roads for cars, right? I'm going to find the road to the right, and I'm going to drive at 10 along that function, and I crash at y equals 7. Well, does 3 equal 7? So what's the general limit as x approaches 10? Yeah, that's D and E. Why? Yeah, mathematically, those cars don't crash. Visually, those cars don't crash. One stops at 7, one stops at 3. You guys with me? Groovy. What's the function at 11, yeah, 11. So that's that vertical line test, where we walk along the line of x equals 10, that's this. X equals 10. I don't hit anything, not hit anything. Oh, I hit something, great. At what y value? 11.
Can you
So-
do, okay, the regular one, just x approaches 10?
What?
X approaches 10, just that third one?
Yeah.
Why is that one does not?
Okay, so let's do the mnemonic first. The three conditions for a limit to exist is the left hand has to exist, check, check. That was 3. The right hand has to exist, check, check. That was 7. And they have to equal each other. So literally, one car has to find its limit, the second car has to find its limit, and those cars have to crash. That's what they have to equal each other means. Those cars have to crash. So if they don't crash, the limit doesn't exist. That's it. That's all there is to it. So how do you guys feel about that? Is it continuous at 10? What are the three conditions for continuity?
The dash on the right side has to be equal, a general limit has to exist. What's the third line?
That is the first one. The limit has to exist. So the subs to that, the subtext to that is these have to exist and they have to equal each other. So this limit has to exist. The function has to exist and they have to equal each other. So let's take a look at x equals 0, just for giggles. Let's say this is x or y equals 5. What's the limit as x approaches 0? So the car on the left and the car on the right, are those cars gonna crash?
Yes.
Yeah, so the limit as x approaches 0 is 5. The limit as x approaches 0 is 5. What's the function at 0? So we're gonna do that vertical walk until, we hit something solid. What's my value?
5.
5. So does the limit equal the function?
Yes.
So is it continuous?
Yes.
Yeah, so this is continuous right here. Remember the Idiot's Guide to Continuity, guys? If you can draw it in that region without lifting your pencil from the paper, it's continuous. What about this one? Can I draw that without lifting my pencil from the paper?
No.
No. Okay, so far so groovy.
So continuous, the limit and the function have to be the
They have to exist and they have to equal each other.
same.
Oh.
And both of those rules are written on the front page of 9.2. 9.2's front page is gold, guys. There's a whole bunch of information on there that you're gonna want, okay? Just hint, hint, judge, judge. Lots of hinting and nudging. All right. La la, oh God. Somebody please give me something else. I don't care if it's like Pitbull, give it to me.
It's a worldwide.
Programming in 6 years, the banana split game or something.
Yeah.
Year or so.
The Bloodhound?
No,
game?
banana split.
The banana split game?
Yeah, like a kid show.
Not Bananas in Pajamas,
I don't know.
because that was like
No.
much later than me. I was the 70s and 80s.
It's
I don't
like,
remember
it's
anything about the
definitely an
banana
earworm.
split game.
It's definitely an earworm of a song. I'm currently suffering through right now.
Well, for crying out loud, look it up and share it with the world.
No.
No.
There's a reason why I'm suffering and not having fun.
What about chocolate milk?
PWD function?
Piecewise defined functions. Okay, so let's do another limit type, continuity type, piecewise defined function. Because guess what? These are all kind of related. 9.1 and 9.2 is all just one big jumble. Limits, continuity, limits at infinity, piecewise defined functions. Yeah, poles, asymptotes. You get the idea. How about this one? This is actually a great example that I did yesterday in my other class, so I'm gonna see if I can get it right. Okay. If I ask you to check for continuity, and if it's discontinuous, which condition fails to hold? I want you guys to be able to answer this in a test. Hint, nudge, nudge. First of all, what makes something discontinuous?
No vertical asymptotes.
Zero on the denominator.
Yeah, poles, vertical asymptotes, and breaks. Right? You guys with me? Poles, vertical asymptotes, and breaks. So what do poles and vertical asymptotes have in common? Say you had it.
You have a zero on the denominator.
Yeah, they divide by 0. Okay. So let's take a look at this right away. What's the denominator on this first little function here? 1. What's the denominator on the second little function? 1. Can you ever make 1 go to 0?
Yeah.
No. I heard a yes over there. Is that you, Brenda? Yeah.
It's early.
1 can't equal 0. Not ever, not know how. X can equal 0. A term with X in it can equal 0, but 1 can never equal 0. So far, so groovy. It's just like disobeys the laws of nature. 1 is not equal to 0. So because we don't have any denominators that we can divide and set equal to 0, there are no holes in vertical asymptotes. So now we're checking for breaks. Remember the 3 conditions for continuity. The limit has to exist, the function has to exist, and they have to equal each other. So in order for you guys to test this, raise your hand if you prefer the pictures to the math. Yeah, okay. So draw, draw a little picture with your action point right here. So just a little line with 3. And I'm gonna color code these. So 4x squared minus 5 is gonna be my function to the left. And in green, x squared plus 2 is gonna be my function to the right. Okay? What is this continuity stuff? Okay. I didn't fill in the holes here because neither one of these has 3 included. So right away, what do you see? Forget the limit, let's look at the function. Doesn't exist, there's nowhere you can plug in 3. Do you guys see that? Does this little picture help? So we don't even care what these functions look like. You just draw a line to the left for your left-hand function and a line to the right for your right-hand function. Fill in or not your circles appropriately and answer the questions. This will really help you guys. So now let's test, well, we know it's discontinuous, so we know that fails to hold because of the function. The function doesn't exist. So the function at 3, d and e, we know that. So it's discontinuous at 3. But what about the limit as x approaches 3? Well, let's check the left-hand side and the right-hand side and just see what happens. So if I go to the left of 3, which function am I going to use? The red one, the 4x squared minus 5. Okay, so let's test that. So 4 times 3 squared minus 5, which is 36 minus 5 is 31. And then the right-hand side is which one? The green one. So I'm going to test the green one. So what was that? 3 quantity squared plus 2, which is 9 plus 2 equals 11. Does 11 equal 31? No. So does this limit exist? No. So conditions 1, 2, and 3 fail to hold, right? The limit doesn't exist, the function doesn't exist, and because neither one exists, they can't equal each other. You guys with me? Raise your hand if you're even the least bit confused, because you will see this on the test.
So because 31 and 11 don't match, that's why that limit doesn't exist.
Cars won't crash. Yep. The left-hand side has to equal the right-hand side for a limit to exist. Okay, yeah, Brenda.
So you plug in the value that, the x, I guess, the x, less than 3 and the x above 3. But what happens if you have that equal sign in the bottom?
Ha! So, let me change this just a little bit. You guys ready?
How fast is just this thing in the middle?
What thing in the middle? This?
Yeah. And you said you can't plug in.
Can't plug in 3 to this. Not when you're doing the function at 3. When you're doing a limit, you're checking what's happening as we get close to 3. So on this side, it would be like 2.9999999, which is functionally 3. So we plug in 2.9999999, and we can see that this one approaches 31, and 3.00000000001 approaches 11, right? So 31 and 11 aren't going to connect.
So this is true that you said because it's an open circle, 3 passes through.
Yeah, so we can't plug 3 into any of
But
this.
if it was solid, then.
If it was solid, then you would have a function. That's right, but you still wouldn't have a limit.
Oh.
You still wouldn't have a limit, because 11 and 31 don't match, right?
What if both were solid?
That's not possible, because in a function, you have to have one unique output for it. Okay? You've never seen a place where you can get 2 answers for one x dot. You've never seen it, and you never will. Not unless you're doing with circles or something like that. Those aren't functions, those are something else entirely. Yeah. Okay, so let me change this up just a little bit.
It's still recording.
Is that what you said? Yeah, you did, didn't you? You know where I'm going. Saeed's got this down. So now let's try this one more time. I'm gonna make this a 25 instead of a 5. So now, when I plug in 3 to this, what do I get? I get 11. So now my limit exists, and it's 11. But does my function exist? No. So this is still discontinuous. You guys with me? So far, so good? Now I'm going to do one more change. I'm going to color code it because I do that with everything. Do it in purple. I'm going to add that little line right there. This guy. Which means this green one is going to get a fill in to its hole. You guys see that? So now the limit is 11, and what's the function? Elena?
I'm not answering that, just how do you know which one is from the left? When you wrote it up.
It's all about the rules. This is all x values less than 3. So this function is to the left of 3. This is x values greater than 3. So this is to the right of 3. It's all about the rules. It depends on the rule. Again, it's all about the rules. This is less than not including 3. So that's an open circle. This is now greater than including 3. So it's a closed circle. It's all about the rules. Those things are like gold, guys. All right, so now we have a limit. It's 11. What's our function?
Plus or minus 2?
I heard a whole bunch of stuff. You said 3. You said
Positive, negative 2?
positive, negative 2.
No?
Look at that.
No?
11.
Wait,
11.
thought you had to.
Yeah, walk until you hit something solid, guys. Oh, so the value of 3 on this function is 11. So now we have a limit that's 11, a function that's 11, and they equal each other. Now this sucker is continuous. Do you see how those little changes can change the entire nature of the function? Just icky-bicky changes.
Yeah.
Okay, so first of all, function at 3. Can I plug it in here? Can I plug it in here? So what's 3 squared plus 2? Yeah, that's all. Visually, I walk until I hit something solid. It's on this function, 3, and this function is 11. Okay? Elena.
Like, when it just says, greater or less than,
Uh-huh.
you already know that it's discontinuous because there's no rules.
That's right, there's no place to plug that function in. Or there's no place to plug that x value in. There's no function that can take that x value.
But if one of them is less or more equal to,
Mhm.
then it can be, but
Yeah.
not necessarily.
Right. Can be, but not necessarily, exactly. So I could revert, I could keep this little equal sign and revert this back to -5 and we'd be back to discontinuous. We would have a function for no limit. You guys with me? Yeah.
So Professor, if I
Yeah.
didn't do that circle, and I just plugged it in,
Yeah.
tell me continuous amount.
Yeah, you don't have to draw this picture if you don't want to.
I'm not sure.
But what I'm trying to tell you guys is this is where you start and this is where you end. The rules guide everything here. They tell us everything about the functions. Okay? Okay.
Because all I had to do was plug it into that. When could I not plug it in?
You can't, okay. When we're taking a function, guys, we're trying to plug an x value directly into these. I realize that it looks the same when we're doing a limit. We're literally plugging that number into the functions, even though it says you can't. Because when we're doing limits, we're driving cars at the function. We're not actually sitting at x equals 3. We're at x equals 2.9999999 and x equals 3.0000001. Okay? So we're not actually plugging it in, we're approximating, okay? But when we're doing the function at 3, the function at 3 needs a place where you can exactly plug in 3, okay? So if it doesn't have a place where you can do that, there is no function, period. Does that help?
Yeah.
Okay. All right, any other questions on this one? Okay. All right.
So one of these is gonna be on the test.
Yep. I'm just gonna say it, yep, one of these is gonna be on the test. Absolutely. Now, let's expand on that a little, shall we? I'm so not awake. Seriously, right? And I would like you guys to check for holes, vertical asymptotes, and horizontal asymptotes, HAs. Alright. First of all, let's start with the first process, holes and vertical asymptotes. We already talked about this. What do they have in common?
0.
Divide by 0, okay? So color coordinate, I'm gonna check the denominator for zeros, possible zeros. So x minus 5 equals 0, x is gonna equal 5. Okay, so that's what holes and vertical asymptotes have in common. So now we know we either have a hole or a vertical asymptote at x equals 5. Now we have to figure out which one. What differentiates holes from vertical asymptotes?
One of them is 0 over 0.
That's right. One of them is 0 over 0. That's holes. And one of these is some other number over 0. So where are we going to plug 5 to check for holes and vertical asymptotes? Into the entire numerator. Yeah. So now we do 5 squared minus 25 equals what? So we get a 0 on the numerator, which indicates a what? Zero. It's a 0. Which one is it? It's a hole. So we have a hole at x equals 5, Christina.
I'm working on it.
Okay. Alright, so we have a hole at x equals 5. Do we have any vertical asymptotes?
Yes.
No. Nah. The only place that goes to 0 on the denominator gives us a hole. That's it.
Right here. X minus 5 times x plus 5.
I'm not asking you to take the limit, am I? I'm asking you to identify places where things happen. Not asking you to take a limit at any specific x value. Were I to say, take the limit as x approaches -5, you would get some answer. If I said, take the limit as x approaches 5, you would get 0 over 0, factor, cancel, retake the limit. We're not taking limits. Does that make sense?
Okay.
Yeah.
Question.
How do we check for horizontal asymptotes, guys?
Use the highest possible.
Yeah.
Yeah, so we do the limit as x goes to infinity, and that's highest power survives. Right? Talked about that? Highest power survives. So what's our highest power here?
X squared.
X squared, and what's the coefficient to that? 1. So when I take the limit as x approaches infinity of x squared minus 25 over x minus 5, I get a survivorship of 1 over 0. I have a coefficient of 1 that survives because that's where the highest power is on the numerator, and I have no highest powers on the denominator. So there's 0. 1 over 0 is what, guys? No.
0.
Does not exist, not 0. 0 is an answer. When you divide by 0, that's D and E. So there are no horizontal asymptotes.
So if I were to do x squared, 1x squared minus 21 x squared.
Yep.
X minus.
If you do the whole math, you'll
then
get
I
1
would
over
get the
0.
same result equal
Yep. But this is faster.
to- Yeah.
Yeah. Any questions about that part?
So we're not checking for the VA on this one?
We did. Saeed, talk to me.
I'm confused now. Okay. So when do we do the thing?
Hang on. To check for holes in vertical asymptotes, you start with the same process. You divide by 0. So we found one place where we can set the denominator equal to 0. So it's either a hole or an asymptote. We're not going to have both. You with me? Now we check the numerator to determine which one it is. If we had 2 sets down here, we could have a hole and an asymptote. And I'm going to flip this, and we're going to do it again, and you're going to see the difference. Okay? Okay. You trust me? Yeah, you better. So I don't know if you guys want your pictures or whatever, but
Also, the vertical asymptote does not exist because the A, we don't have anything.
that's right. When you plug your potential for a vertical asymptote into the numerator, you don't get some number, you get 0, which indicates a hole. Okay?
I'm not just something, but still.
Where did I lose you guys? Emily's going, oh hell no too, so.
So both are divided by 0, so both are 0. Now to get the A on the top, in order to make it, to find the vertical asymptote.
Yeah.
Oh, I see, okay, so you plug, once you find the 5, plug it into the equation,
Right?
and that tells you that the top part is now 0.
Yeah. So you've already established that this is going to take the denominator to 0. Now find out what it does to the numerator to see if it's a hole or an asymptote. Makes the numerator go to 0, it's a hole. If it makes the numerator go to any other number, it's an
Then you-
asymptote.
Okay.
Okay?
So there was another thing that we learned when we got the zeros and we would factor out. That's totally different.
That's different. That's what Saeed was saying. That's when you take the limit as x
Okay.
approaches a number.
And you would say
And
that-
if you get 0 over 0, you still have to find the limit.
Okay.
The factor, cancel, retake the limit.
Okay.
Okay, you identified a hole, but you have to keep going. Oh, yeah, this is 2 different animals. Okay. You guys got your pictures? I'm gonna erase this and do it again.
Real quick on the highest power.
Yeah.
Why did you get one?
Okay, what's the constant coefficient to our highest power term?
Oh,
1. If this was a 4, you would have gotten 4 over 0. Okay? All right.
And then the bottom, there's no highest power.
Yeah, there was no highest power present on the denominator. So now I'm going to flip this. X minus 5 over x squared minus 25. All I did was reverse them. Now you with me, Sadie? Good. Okay. So the first thing we're going to do is check for those holes in vertical asymptotes. Step 1 is find what makes the denominator go to 0. So x squared minus 25 equals 0. X squared equals 25. X equals the square root of 25. X equals positive 5 and negative 5. So now I have 2 places to check on the numerator. You guys with me? So what do I do next?
Plug in those values.
Yeah. So I'm going to check positive 5. So positive 5 minus 5 equals what? 0. We have a hole at x equals positive 5. We're going to check negative 5. Negative 5 minus 5 equals negative 10. That is any other number. This is a vertical asymptote at x equals negative 5. You can graph these guys to check your work. You can always graph the function to see if it does what you think it's going to do. You think you have a vertical asymptote at negative 5? Graph it. Verify it. You have your calculator. It's a tool. Okay, so now we have a hole and a vertical asymptote this time. Now let's check the horizontal asymptotes. You guys ready? So we're going to take the limit as x approaches infinity of x minus 5 divided by x squared minus 25. What's your highest power? 2. So the constant coefficient here is 1. Do we have a highest power on the numerator? No. So we get nothing over 1, which equals what, Christina? 0. That's an answer, guys. We have a horizontal asymptote at y equals 0. And that's how we do this. Hi, Brenda's phone. Here's my phone. Oh, hi, Emily's phone.
So could you just go one time?
I got it.
And you could just quickly over it. So you are checking for whole vertical asymptote and horizontal.
Yeah.
And now we've got divided by 0.
I know it's exactly.
So we got that. Plus 5 minus 5, then we check. So when we're checking, that's where I was
Look at where we're plugging it in, Maria. Hey, guys, she needs to be able to hear me. Look at where I'm plugging it in. I'm plugging this into the numerator. I'm checking it in the numerator. I've already established that the denominator goes to 0 at these 2 x values. Now I'm checking it against the numerator to see which one it is. So first I found the thing that they had in common, and now I'm differentiating between them by checking the numerator, because that's what is the difference between holes and vertical asymptotes, is the numerator. Okay? So that's what this step is. All right? Elena.
When you take the limit and the horizontal, yeah, how do you get the 0?
Okay, so I have the highest power. In this case, it's x squared. So I only have one x squared term, it's down here. So the 1 comes from that constant coefficient right there. That's what's going to survive. Are there any x squareds up here? So nothing will survive. For example, just really quickly, if I had a function that looks like this, if I did the limit as x approaches infinity, my highest power, Helena, is what?
4.
You guys are not Helena. Helena, I want her to answer this, guys. Yeah, it's gonna be x to the 4th. So I have a -4 in front on top here. That survives. And I have what on the denominator here? 1. So I will have a horizontal asymptote of y equals -4 on this function. Because the highest power determines the end behavior here. Okay? So all these other parts of this function are going to disappear as x gets really big. They become unimportant because the highest power determines that end behavior. Does that help a little bit? Okay. All right. Sorry to shut you guys down, but I wanted her to synthesize this. Okay. Question so far?
So that would be like the quickest way to attack the problem.
Absolutely. If you're asked to find horizontal asymptotes or the limits at infinity, that's the process. Highest power survives. Okay. And they do one and the same thing. Finding horizontal asymptotes is taking the limit as x approaches infinity. It's the same thing. What else, guys? If you don't look happy, good? Does it make sense? How about all my other quiet chickens? You guys good? Quiet ones? What's up? Yeah, that makes me so happy. Yeah, no? Sort of ignore the center here. I want to make sure you guys are got. Okay.
One more time.
That was a 4. That was number 54. That takes us through piecewise defined functions and limits. How was that? Not so bad.
I just realized 54
What?
isn't even a number.
What?
She always says 54, this isn't even a number. You only give us odds.
Saeed, what did you ask for?
I asked for 54, not 44,
Why did you ask for an even number? That's a great point.
because that's what you gave us.
But I didn't. I said never pick an even number.
We have 150, every other odd, every just demand, and you specifically asked for number 54.
Did I really? No. Saeed, I have no idea what that was. Honey, I'm sorry. But if you have questions over number 54, my dear, you and I can go over them together. Absolutely. Products and quotients in the applications.
I think what he said was, and I have it recorded, is 1 to 34.
Uh-huh. Every other odd.
Yeah, so because the 34 was added in,
But 54 is,
the 54 might be thinking 54, but it was 34.
Saeed? I have no idea. If I gave you an application problem, I named it, first of all. And if I named it, you can find the odd version of that in your textbook. If there is no odd version, don't do it. Right.
I think we need just 3 a.m. I thought they were doing
And that's the T. When are they due, guys? On the test. How are you gonna turn them into me? on the front, arrange them in chronological order, staple the hell out of them, and hand it in to me. That's it. Hold on to them for a couple more days, okay, Saeed? All right. At least he's done, yeah, exactly. All right, product quotient and ask. Let's go to 9.4. No, 9.5. Okay. Here's an even revenue problem. This, in my edition, is number 42 out of 9.6. No, 9.5, I lied. And it's got a revenue function equals 3,000. No, 60x squared. It's useful if I look at it. No, I'm doing the 42. I should be doing the 3,000. Sorry, guys. La, 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 la.
So an even problem?
Yeah, I gave you the odd one. Plus 80x minus 1,500. And it wants you to find the marginal revenue when 149 units are sold. Find and interpret. Marginal revenue. When 149 units are sold. Okay. How am I gonna tackle this, guys?
Derivatives?
Partial
Yeah, find the derivative. Quotient rule, it's a derivative. Plug in 149 into this function. Into the derivative, good. So let's unpack this, guys. Marginal revenue is the derivative of revenue. When 149 units, so we're finding marginal revenue at 149 units, okay? So we're first finding the derivative and then we're gonna shove 149 in and see what happens. So far, so groovy. All right. How many of you wanna treat this like a quotient? How many of you wanna treat it like a power? Okay, so you would do D out D in on this, how would you tackle that? Yep. So he would rewrite this as, what's your name again? Alex. He would bring it up and change the sign. What he's doing is he's giving it a power of 1. He's wrapping it, giving it a power of 1 and dragging it uptown so that he can just do D out D in on it. And that works too, you guys. You can totally do that. But since you guys asked for product and quotient, I'm gonna go ahead and do it the old-fashioned way. So now marginal revenue is gonna be U prime times V minus U times V prime divided by V squared. That's the first term done. What's the derivative of 80x?
80.
Good, and what's the derivative of minus 1,500? We killed it, killer, exactly. Good. So now what?
Like,
That's my derivative. I could clean it up a tiny bit and say that this entire thing is gonna go to 0. And just leave negative 6,000 over 2x plus 2 quantity squared. So I clean it up just a little bit. so that it makes it easier for me to plug and chug. Right?
Professor, this is the power rule that you're doing, right? The way you wrote it.
He would be doing the power rule. I didn't, I did the quotient. U prime V minus U V prime over V squared. Okay, so now I plug 149 in and just see what happens. Marginal revenue at 149 is negative 6,000 divided by 149 times 2 is 298 plus 2 is 300. And I'm gonna square that plus 80. So that looks like fun. Negative 6,000 divided by 9, 1, 2, 3, 4. I'm gonna kill some zeros there. Plus 80. I'm bored. Let's solve this. What's negative 6 over 90? What? Maybe negative 0.6667 or 0.06667 plus 80 is 79.93. Am I done?
Now,
Now, I got the find. Did I get the interpret? No. So how do I do that?
so you want to see 1 unit of difference essentially from 149 to 150.
Good. So the 150th unit sold increases revenue. Yeah. By approximately, remember these are all guesses, $79.93. So what was the hardest part in this problem, guys? Emma?
I guess finding the derivative of the marginal revenue, just like rearranging that.
Yep. Finding the derivative of the marginal revenue, absolutely. Are you guys working in a vacuum in the test? Absolutely not. Unless you're taking it in the Access Center. It's a vacuum, because I won't be there. I'll be sitting right here, guys. Right here. Come talk to me if you need a nudge. I'm not gonna throw you in the deep end and let you drown.
How many questions would be on the exam?
5 to 8. But they're multi-part questions, so depends on how you like to define a question. Depends on what your definition of the word is. For those of you that, yeah. Yes.
Can we do it if we do it as a power rule? Could you show us how to do it?
Yeah, of course. So you know you're gonna end up with negative 6,000 over 2x plus 2 quantity squared plus 80, right? Let me show you how. So if I take the derivative from here, marginal revenue is gonna be D out, so negative 3,000, junk, to the negative 2 times dn, which is 2, plus 80.
That was so much easier.
So now, Emily, tell me the elements, once you get done writing it. Tell me the elements that we have here. We have a 2 and a negative 3,000, which make, there's that. And we have a 2x plus 2 to the negative 2, which if we yank downtown, looks like this. And then the 80 is the 80. Does that make sense? So pick a poison, guys. Either one will get you there. Yeah. Units and thousands. Wouldn't have the zeros. That's why you have to go back and R that F through a few times if necessary. Make sure you got all the elements necessary. Okay. It also helps to write out that kind of stuff. So you see it right away, highlight it, or write it out right below so that you remember that it's there. It doesn't get buried in the question. Just add added it yet. Yeah, usually you add it yet, occasionally you have to incorporate it. And in that case, I'm probably not gonna count it. Okay. All right, how do you guys feel about this problem? How many of you are vastly overthinking these? Stop it. Stop it. Don't do that to yourselves. Yeah. Well, that was a revenue and a product quotient. That was fun.
What was that?
Some nested functions, I absolutely can.
It'll be really easy.
But before I do, Saeed asked for 9.4. I believe it was number 54. Was that a cost and average cost problem for you? Okay. Are you working out of this edition? No, okay, so maybe not. I'll wait for you. It's what?
I can't.
Really?
I don't feel good.
Me either.
Oh, the 12th edition. I'm looking for a 12 in my numbers. I'm like, I don't see it. That's okay.
Are you coming to normal study group?
Because we have time to do nested functions and this.
Oh, normal.
Since he asked,
Because she's not gonna be here.
I'm gonna do it, just for giggles.
I know. I don't feel good though.
Poor guy.
And I've been
Sweating
working a
back
lot,
there.
so I'm just like so over it.
Ah!
How would you do the nested or then when you get so you can think?
Ah, he's almost there, Maria. It's okay. I got you both.
We're never taking an A another.
Dude, that was a little disappointing tonight. And that was not like sure. No.
Does it have 40,500 in it? Okay, good. Okay.
I take the worst classes.
So I have cost equals 40,500 plus 190x plus 0.2x squared. And then it gives average cost in part A, which you guys already know is this entire function divided by x. So if I divide this by x, I get this. If I divide this by x, I get this. If I divide this by x, I'll get that. It wants you to find the instantaneous rate of change of average cost. So which one are you going to take the derivative of? The second one. Is it pretty?
No.
Can I make it pretty?
Yes.
I'm just going to write that as 40,500 x to the negative 1 plus 190 plus 0.2x. And this is my average cost function. So now what's my derivative?
Negative 40,000.
X to the negative 2. What happens to 190?
Killed it.
You kill it, killer.
Plus 0.
Plus 0.2.
Aha, you were about to
I
write.
almost did it.
Dang it.
I almost did it. Sorry. Maria, you found a mistake. Remind me to remind the class after this problem is done, okay? All right. So that was not bad. Can I rewrite this so that that's pretty again?
Yes.
Negative 40,500. I'm going to drop the x squared downtown plus 0.2. And this is still my derivative of average cost. Part B. Find the level of production where this rate of change equals 0. Saeed?
So for the average, we just divided it by 10x.
Yeah, that's it. Yeah. So in the basics of business, in the context of this class, and I do believe in the application section, I touch on that both times. Average cost is just cost per unit, or cost divided by X. Okay? Yep. Pretty? So how do I set this equal to 0 and solve?
The average cost.
0 equals negative 40,500 over X squared plus 0.2. How do I solve for X squared? Yeah, I'm gonna get this over here, or maybe I'll just move this over here. Get some positive numbers. Whoops.
What are you finding in this 13?
We're finding the X value where the slope is 0. So I have my derivative, I set it equal to 0, now I'm solving for X. If I multiply both sides by X squared, and I divide both sides by 0.2.
Okay.
I have no idea what that is. That's 20. And then 2500
Yes.
equals X squared. Somebody check my math? Yeah? Okay. And then X equals the square root of that, which is what, guys?
I don't know.
That looks real good on video. I'm trying to eat spiders dropping. Okay, that's not. Thank you. Ah, you're awake. Hi. No, you've been awake. I'm kidding. It's just the first time I've seen you smile this morning. So I happen to be looking in the right direction at the right time. Spiders did it, huh? It's technically plus or minus 450, isn't it? But what are we gonna toss?
The
Minus.
negative.
Why? What is X? It's production.
Such
Can you make
positive.
negative things?
No.
No.
Children.
I mean, you can make things that have negative connotations, but you can't make negative number of things.
Yeah.
Right? So we're gonna keep the 450, the positive. There, that wasn't so bad. Saeed, was that where you were struggling? Okay. We'll stop there on that one. Let's do a nested function. So grab your pictures.
This might be an exam.
I'm so excited, you guys. Because you're a third done with the class
Yeah.
today. You're 1/3 done.
Yay.
Can you believe it?
No.
This
guys
was,
are-
this was the hard part.
The what?
The harder third.
No, yeah, this is the hardest third, I think. I think it is, yeah, I do.
Kind of gets easier.
Because now we're just expanding on stuff we already know, right?
Right, like the double derivative.
Yeah. I mean, we all know what a derivative is, we know what a limit is. We know how to manipulate application functions, I hope.
Wow, just attitude.
At least I can write
I
out.
hope.
It's like, if you,
How about this?
you specifically failed this class, what's wrong?
You gotta go.
Make that a fourth root. Is it pretty?
Nope.
Can we make it pretty?
Yes, ma'am.
Yeah, how do we make it pretty?
It'll be all of that to 1/4. Yes, queen.
Oh, man. I'm gonna bracket it to show that. And give you guys a second to think about it. Okay. It's okay. I got you. Remember, peel one layer at a time, Christine. Okay? One layer at a time. So on the outermost layer, what is it gonna be?
Before you can touch your junk.
It's a product, a quotient, or a
Thought about
power?
that last night.
It's a power. Good. So globally, we're going to be using, what is so funny?
Nothing. The peeling.
The peeling. You have to.
We're gonna peel. Yes, we're gonna peel. So start with the outside layer. 1/4 jump to the what power, guys?
To the 4 minus, or 1 minus, -3.
What's 1 minus 4? Yeah, -3
Over 4.
fourths. What goes in here? The junk. Do we touch the junk?
No.
Not until we fully peel off the outer layer, guys. Okay. Now let's do the derivative of the inside, which is a what?
What quotient?
Just look at the inside stuff. That is a
Product.
product. So we're going to use u prime v plus uv prime. What's u prime?
3x squared.
And v was 2x squared plus 10x cubed plus u, which is x cubed minus 5, times v prime, which was 4x plus 30x squared. Close my parentheses and my brackets. I is done. This is just an expanded form of d out dn, guys. That's all it is.
So this whole thing is the answer.
Yeah, that's it.
It's a long
You
answer.
just solved my problem because I was thinking chain rule and I
Oh,
was
you can use the
forgetting
chain rule.
And then when I was doing chain rule, I did
fell
the
into
chain
the
rule,
weeds.
but then I was doing the chain rule or
I just want to check the x
instead of doing the product. But if I stay with the power, then I see the product.
Exactly. So we have about 5 minutes left, guys. Any other weird topics you want? Yeah, Helena.
So this is
Oh crap! I erased it with my back.
plus u.
Which bracket?
Prime.
Do that if like, let's say all of it was 2
If this had a power, you would need to include the brackets, but you still need to include the brackets. Let me show you why. If I take these brackets out right here, what is being multiplied to this? Just this term. Then this gets added on to the end. We want the whole thing to be multiplied. So I bracket it to make sure that it indicates multiplication across the whole thing. Does that make sense? Okay. That's a great question. Yay. Absolutely. Yeah, of course. Do it in green.
Why is there no addition in the middle?
Why is there no addition in what middle?
Like after the 3/4, like the 2.
Like right here?
Yeah.
Because the global function is a power, so we're doing d out times dn.
Okay.
Okay, d out dn. And then on the inside, we have u prime v plus u v prime. Does that help? Yeah, you're welcome. What if we had something extra to read the original function? That's so extra. Well, what's the derivative of 10? What if it were 10x? What's the derivative of 10x? Yeah, so what I'm trying to say here is, does the derivative of this have anything to do with the derivative of that? No, because when you separate terms by pluses or minuses, you go separately. So if I had a like plus 15x over here, the derivative of this has nothing to do with the derivative of the plus 15x or the minus 15x squared or whatever is coming in here. Okay, so we have a term and then I can just throw it on at the end on a different color. Plus 15x squared plus 15x squared plus 30x. It wouldn't change anything, except it's on the same.
Oh, you mean it's like outside that?
Yeah, if it's outside that action, it has no part of that action. It has its own action.
Oh,
Okay? How big of a cheat sheet are you allowed?
8.5 by 11.
A page. Don't waste your time with 3 by 5. You'll be sad. Both sides or one side? One side, so I don't have to listen to this. Where is that? I know it was here. I know it was here. It's here somewhere. One side. Handwritten. No shrinkage. Don't write it and then shrink it, write it and shrink it. No, handwritten. It's gonna get turned in with your exam. Can you put anything on it?
Yes.
Anything you want?
Yeah.
Anything at all?
Uh-huh.
Worked problems, examples, graphs, pictures. Sure, if you're wrong. Unicorns barfing glitter, I don't care. Whatever helps you to remember this stuff.
A tomato.